Guys, coming at you with another awesome video about math. This time we're talking about graphing linear equations in slope-intercept form. I'm going to go through two definitions, one of a linear equation and the other one of slope-intercept form. Then I'm going over whopping four examples of graphing linear equations. So let's take a look at that. Okay, here is this. So this is what is a linear equation. An equation between two variables that results in a straight line when graphed. Those two variables are typically x and y. It's also good to know that the rate of change on a linear equation is constant. And we'll talk about what that means. Next. What is slope-intercept form? Y equals mx plus b is slope-intercept form. It is not the only form of a line, but y equals mx plus b is known to be easier to graph. In this case, m is the slope of the line and b is the y-intercept. Rise over run refers to the slope. Typically you hear it written that way because it's in the form of a fraction and we're moving up the y-axis or the vertical, then horizontal. Y-axis, then horizontal, or vertical, then horizontal. X is commonly referred to as the input and y is commonly referred to as the output. We'll talk about that as well. Alright, let's go over our four examples. So now, example 1. This is a positive line, and I'll explain that to you. And this is 2 over 3x plus 4. The slope here, which I'm going to write in a cleverly chosen blue marker, is going to be 2 over 3. So that's rise, run. The y-intercept is going to be 4. So here's how I'm going to graph this. I'm going to start at 4. Then I'm going to go up 2 over 3. Up 2 over 3. So one more time, up 2 over 3. You don't need that many points, but I just want you guys to see the example as clearly as possible. Now, I'm going to draw my line. There it is. And this is the line y equals 2 over 3x plus 4. Now I want you to recognize something here. We talked about constant rate of change and input and output. So I'm going to go to the solid or the whole number x values here. Those are my inputs. So for example, this is 3. This is 6. This is 9. And that pattern will continue. The next one up over here is 12. That's not coincidental. The pattern also, so these are the inputs, and the pattern also continues along with the y's. And it's not coincidental about the distance between them. You should, hopefully, be able to see a pattern. So that's 6. This is 8. And that's 10. And can you guess what this is going to be? Okay? So, right, I'm hoping that you could kind of start figuring out the pattern of how they're rising and going, but I'm not going to address that now. Next. This here is negative 3 over 4. X minus 2. It's a negative line. And we're going to talk about how to establish the difference between them. So m here equals negative 3 over 4. So we're going to go down and run. And the y-intercept is negative 2. So, just like before, I'm going to start at negative 2. I'm going to go down 3 over 4. 1, 2, 3, 4. There we go. Down 3 over 4. Alright, and now I'm going to draw my lines. So, Here we go. And there's the line. A little crooked. I was kind of in a rush. Haste to waste here. So let me clean that up. Alright. There we go. So now this is the line y equals negative 3 over 4, x minus 2. And once again, I just want you to see very quickly that the inputs or the y values are staying constant. That's 4. This is 8. And I bet you can guess what the next one would be. And the same pattern is going to go along with these. So this here is 5. And this is 8. Okay? So that's that. Next. Okay. Here, we don't have a number up front. There's no coefficient there. That's what the other slopes were. But in front of every x is a 1, and it has to be there. So m here is 1 over 1. And the y-intercept is 2. So now I'm going to graph that. So this is 2. I'm going to go up 1 over 1, up 1 over 1, and continue. Then I'm going to graph that. Okay. Now, here's what we want to talk about. Let's talk about this here. The positive and the negative lines. So this guy here, as I bring my ruler over, you will see the line climbing up the ruler. That's why it's considered a positive line. Another way I like to look at it, so we read these left to right, is I put one of my triangle critters here. Well, they're not mine, are they? They belong to everybody. So, and he has to decide if he wants to push his way all the way up this line or hike up the line. Let's take a look at the other one. So the last one here, this is a negative x minus 1. So here, the slope is negative 1 over 1 because that coefficient of 1 exists, and we could take 1 and turn it to 1 over 1. The y-intercept is also negative 1. So I'm going to go to negative 1. This time, instead of climbing up, I'm going to climb down. There we go. And I'm going to draw this line. Okay, there it is. And I keep messing up my negative lines today. So let me try that one more time. Alright, there it goes. So now, that's the negative line. Now what I want you guys to recognize is, again, when I read this from left to right, look how it's going down the ruler. Okay, that's why it's called a negative line. Another way to look at it is if I put one of my triangle critters here. He's got to decide if he's willing to go sliding down or tumbling down this line. Okay, we're still reading it from left to right. I'm going to try to put these side by side each other so you can see the difference. Positive line, he's got to climb up. Negative line, he's got to slide down. Reading it from left to right. Alright guys, I hope you found this video helpful about graphing linear equations in slope-intercept form.